So today we're going to learn how to find the distance between 2 points on a graph using the Pythagorean theorem. Now there's different ways to find the distance, but in the 8th grade core it requires us to use Pythagorean theorem to do so, so that's what we're going to do. Just a quick reminder of what Pythagorean theorem is. Of course, it's involving right triangles. We have legs A and B and a hypotenuse C. And they always relate to each other using a squared plus b squared equals c squared. Make sure that you've done the Pythagorean theorem assignment before you try this one. So this is kind of where we're going with this. We want to find this distance between points A and B. It's, not easy to count off. We can't just count because notice how it goes through partial squares, it goes through diagonals of squares. So it's not really a super easy distance to find. However, we're going to use horizontal and vertical lines to make ourselves a right triangle. Well, as right as it's going to be in my picture anyway. Here's our right angle, so these purple lines are the two legs. Those are going to be A and B. And the green line, the distance that we want to find, that's going to be C. And the distance we want to find today will always be C. You're going to create legs A and B. Now I could have made my horizontal and vertical lines this way, right? It doesn't matter really which direction you go as long as they're horizontal and vertical lines. Now this is the triangle I'm going to use to help me find what I need. So really quickly, on a vertical line like A, right, I can actually count the number of spaces that line crosses to find the length of this line. So for instance, this line is going from -3 to +7. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. This side has a length of 10. This side here, side B, or leg B, goes from -5 to +7. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So B would have a length of 12. And I can use those two legs to help me find the hypotenuse using Pythagorean theorem. So this is what we had in our picture before. And if you couldn't see it very well before, remember this side went from -3 to +7. So we have 3 spaces here below the x-axis and 7 spaces above. That means that this side has a length of 10 units. Side B, or leg B, has 5 units to the left of the y-axis and 7 units to the right. That's kind of where we got the length of 12 units. So now I would use Pythagorean theorem to help me find my missing length C. So again, if a squared plus b squared equals c squared, and a is 10, that means 10 squared, and b is 12, that's going to be 12 squared, has to equal my missing side length squared. 10 squared is 100. 12 squared is 144, has to equal c squared. Combining like terms, I'm going to switch this around a little bit. Tells me that c squared has to equal 244. That means c has to be the square root of 244. Remember, in the very end, we're always going to square root when we're using Pythagorean theorem. So I'm going to put in 244. I'm going to square root that number, and I'm going to round to the nearest tenth. or 1 decimal place. That's going to give me 15.6 for my answer. So I'm going to say that C is going to be about 15.6 units. Today, this word right here is going to be hugely important to your assignment. Make sure you put the word units at the end of every answer. We don't know what kind of units. We don't know that these are centimeters or inches or feet or yards or miles. We're just going to put units to get ourselves or to keep ourselves in the habit. Here I have another set of points that I need to find the distance between. Again, I'm trying to find this length from A to B, from point A to point B. I'm going to use horizontal and vertical lines to make a right triangle from point A to point B. I'm going to count those distances. This side goes from -3 to +5. 3 plus 5, this side has a length of 8. And I can count that off if I need to. This other leg goes from -2 to +6. 2 on this side and 6 on this side. This has a length of 8 units. Here's our right angle, which means that this is side C, our hypotenuse. So I'm going to use, again, a squared plus b squared equals c squared. 8 squared plus 8 squared equals c squared. 8 times itself is 64. When I combine like terms, I'm going to switch this around just because I can. 64 plus 64 is 128. That means, of course, that c itself is going to be the square root of 128 because I'm looking for what number times itself is equal to 128. So we're going to bring out our handy dandy calculator and find the square root of 128. Rounding to the nearest tenth is going to give us 11.3. So C is going to be 11.3, and what word are we going to put at the end? Units. This would be my final answer. Let's try one more just to make sure that you have this down. Again, we're trying to find this length from point A to point B. I'm going to use horizontal and vertical lines to create a right triangle out of that so that I have C for my hypotenuse and legs A and B. It doesn't really matter which one's A and which one's B. How long is leg A? Count it out. See what you get. Hopefully you got 8 units. How long is side B or leg B? Count it out and see what you get. 6 would be the right number of units. So now we're going to put that into Pythagorean Theorem. A squared plus b squared equals c squared. One of our legs is 8. One of our legs is 6. 8 times itself is 64. What's 6 squared, or 6 times itself? 36. Combining like terms, 64 plus 36 is equal to 100. That means C has to equal the square root of 100, which is 10. And of course, I can't forget to put the word units on the end. Our hypotenuse, or the distance from A to B, is 10 units. Make sure to write any questions down so you don't forget to ask me them in class yesterday. For your 5 points for watching the video, would you write the answer to this last example, that this distance is 10 units? I will see you tomorrow in class. Our assignment is going to be the distance using Pythagorean Theorem worksheet. Have a good night. See you tomorrow.